Let's try evaluating this function. The function is f at x equals 2x plus 3, and first it asks us to find f at 2. Well, that just means take the function, 2x plus 3, but in the place of where you would have had x, you replace it with the number 2. And now it's just a question of evaluating. 2 times 2 is 4, and 4 plus 3 equals 7. Sometimes you're given a evaluation which requires two pieces. So on the side here, first I'm going to calculate f at 2, which I already did before, but I'll show my work again just in case this was a different question. F at 2 means replace the 2 in the place of the x in the equation. So I get 2 times 2 plus 3. And I could do all that at once. 2 times 2 is 4, plus 3 is 7. I'll take a bit more time solving for g at 1. Oh, there is no equation g at 1. I better write an equation down. Let's say that g at x equals 4x minus 7. And let's say those are the two equations you were given. I just didn't write one of them down. Okay. G at x, which in this case is 1, equals, now sub 1 into 4x minus 7, you get 4 times 1 minus 7, which is just 4 minus 7, or negative 3. So I know f at 2 is 7, and g at 1 is negative 3. In other words, I want to add f at 2, that's 7, plus g at negative 1, that's negative 3. 7 plus negative 3 is 4. And finally, sometimes I'm asked to evaluate twice in a row. In this case, I'm asked to evaluate g at 2 first, and when I get its answer, put it into f. So I'm going to leave f on the outside, and I'm going to find out what g at 2 is on the side here. So g at 2 is equal to 4 times 2 minus 7. I just subbed in. 4 times 2 is 8, so we get 8 minus 7, which is 1. So I found out that this g at 2 quantity is equal to 1. I put that in the brackets for f. And now I can solve what's f at 1. I can do it on the side, or I can do it here. I'm going to continue here. What's f at 1? Well, it just means take this equation and sub in 1. Instead of x from 2x plus 3, we write 2 times 1, that's our x, plus 3. And 2 times 1 plus 3 equals 5.